first. Generally, a minimum maximum point, we'll call them as turning points. If it's not turning point, you can also call them as stationary point. Now, these points, in order for you to find their values, you must equate dy over dx to 0. Now, the second thing is that if these points, they are minimum point, then you'll have to do the second derivative and that value will be more than 0 or positive. Then you will know it's a minimum point. But when you do the second derivative and you realize that the second derivative is less than 0, then you will know it is a maximum point. Now, what's minimum, what's maximum? So if I have a curve here, this point here is a turning point. Here is also a turning point. I can call both of them the turning point. And at this point, what will be the gradient? It's going to be 0, which is why I said dy dx at this point is 0. And dy dx here is also 0. Now, what else can we say? This is the highest point, right? So we call this as the maximum point. And this point is going to be the minimum point. Understand? So when we are saying it's a turning point, dy dx has to be 0. And if you want to determine whether the turning point is minimum or maximum, you do the second derivative. If the second derivative is positive, it's going to be a minimum point. If the second derivative is negative, then it's going to be a maximum point. Okay, and this is what a maximum point is, minimum point is. There are also local minimum and maximum. That is not covered in your syllabus, so I'm stopping here. Understand, guys? I'll find dy dx because you know if it's minimum or maximum doesn't matter. But as long as it's a turning point, dy dx have to be equal to 0. So this is going to be 4x minus 8. Now, this is the first step. Second step is going to be 4x minus 8 equals to 0. From there, we can find our x as 2. Now, let's see whether this is minimum or maximum. I'll do the second derivative of this. So, I will get 4. 4 is more than 0, therefore, it is a minimum point. Now, we know this is minimum. Substitute back into the equation and you can find your y value. So, your minimum point is going to be and we are done. Okay guys, in this question what we are going to do is that we are going to try to find the dimensions of a rectangle so that the area is maximum. After finding that, we'll find the maximum area. So this is a rectangle. In that case, let's get an expression for it. A, the area of the rectangle is going to be breadth times length, so it's going to be x times with 50 minus 2x. You will get 50x minus 2x squared as the area. This is the area. We just expand this. Okay. Now let's differentiate this. dA dx is going to be 50x will become 50. Excuse me. This is going to be negative 4x. Now remember I said whenever you want to find a turning point, you have to equate dA dx to 0. So 50 minus 4x equals to 0. Minus 4x equals to minus 50. And x is going to be 12.5. Now we need to know this 12.5, it's actually meters, whether it is minimum or maximum. So what did I do in the previous question? I'll have to re-differentiate again, get a second derivative and find if it's positive or negative. So will be negative 4. Negative 4 is less than 0, therefore it is a maximum value. So Now that we know this is the maximum value, I'll redraw and substitute the values into this. So x is going to be 12.5 meters. These are the dimensions. 50 minus 2 times 12.5, how much do you get? 25 meters. So the dimensions are 12.5 meters times 50 meters. Okay? Now the area is very easy. It's going to be 12.5 times 50 meters square. How much is that? Can someone calculate for me? So based on this, we know the dimension is going to be 12.5 times 25. Now the maximum area will be 12.5 times 25. How much is that? So you see here now, they want you to prove that the area of the shaded region is 40x minus bracket 4 plus pi over 4 close bracket x squared. Now to do that, firstly, another information is given here that the perimeter of the rectangle is 80. How do you find the perimeter of the rectangle? So perimeter is going to be that's going to be y plus x plus y plus x. So that is 2y plus 2x equals to 80. Now I can take the 2 out. So y plus x is equals to 80 divided to y plus x equals to 40. Okay. From this, I'm going to make y as my subject because you see everything else is in the form in x terms. So somewhere when we're doing the question later, I know we are going to replace the y with x, substitute y with x. So let me just get the expression now. It's going to be 40 minus x. We keep it aside. Okay, let's go on to the next part. You want to find the shaded region. Now, first, let's find the area of the rectangle. That is going to be y times x. See, now we saw y is equals to 40 minus x. I'm going to substitute that into this. So 40 minus x times x. Expand that. 40x minus x squared. This is the area of the entire rectangle. Now, how am I going to get for the circle? Do you realize the diameter of the circle is x? So, based on this, the radius is going to be x divided 2. Okay? So, I'm going to do that here. For the circle, the radius is x over 2. So, area equals to pi r square, pi times x over 2 square. What do I get here? So, the shape so A is equals to the entire region, which is 40x minus x squared minus pi x squared over 4. Now, if you realize here, this 40x is already out, but they did something here. They made it into one term, which is why you have over 4. So we have to modify a bit. I'm going to put over 1. Make the denominator the same. Over 4. Now, if you see, both have negative here, but here it's plus. So that means they took the negative out. So you'll have to look at the given expression and you'll have to change a little bit. So that leaves me with 4x squared minus pi x squared over 4. Negative, negative, sorry, will become positive. Now, both the terms has x squared. What if I factorize that out? Now, it's the same, isn't it? 40x minus 4 plus pi over 4 x squared. So this is our final answer. X squared will become 2 bracket 4 plus pi over 4x. Okay, you can simplify this. I can cut this and this. That will make it 40 minus x. And whenever we want to find minimum or maximum, we have to equate that to 0. So 40 minus 4 plus pi over 2 x equals to 0. Now 40 is equivalent to 4 plus pi over 2 x. Bring it to arc. So x is going to be 80 over 4 plus pi. We also know that based on this, you also know you can also find your y value. But before we find that, we need to ensure that this is minimum or maximum, because they want the area to be maximum. So again, our dA dx is this. You'll have to differentiate this again to get a second derivative, which is negative 4 plus pi over 2. Correct? Now, based on this, do you realize pi is positive? We don't have to fully calculate that, but you can already see this entire thing is going to be negative, which is less than 0. Therefore, it is maximum. Okay? Now that we know this is maximum, let's look at our x value. I can easily calculate my y value. Based on the equation we got just now, we know that y is equals to 80 minus, it is actually 40 minus x. Value is going to be 40 minus 80 over 4 plus pi.